Now, the hybridization of carbon is fairly easy to predict. First of all, you have three types of hybridization. You have sp3, sp2, and sp. When a carbon is sp3 hybridized, it only has sp3 orbitals. That's 4 of them. When it's sp2 hybridized, it has 3 sp2 orbitals and 1 p orbital. Sp hybridized, 2 sp orbitals and 2 p orbitals. What this means? Well, a sigma bond must use a hybrid orbital. A pi bond, you must use a p orbital. So, if a carbon has 4 sigma bonds, then it has to be sp3 hybridized. If it has 3 sigma bonds, then it can be sp2 or sp3 hybridized, depending on what that 4th bond is. If it's a pi bond, then it's sp2 hybridized. If it's a sigma bond, then it's sp3 hybridized. 2 sigma bonds means that it is either going to be sp hybridized or sp2, depending on what else it is. It could also be sp3 hybridized as well. So, let's take a look. At, say, the atoms in cyclohexene. This carbon right here, well, we have 3 bonds to it that are shown, so carbon always has 4 bonds. So that means it has a hydrogen. This carbon here, and marked, has 1, 2, 3 sigma bonds. One to this hydrogen, one to this carbon, and one to that carbon. And it has 1 pi bond. Since it has 3 sigma bonds, 1 pi bond to it, this carbon here is sp2 hybridized, because it needs the 3 sp2 orbitals to form the 3 sigma bonds, and then the 1 pi bond is formed using the p orbital. The carbon adjacent to it, this one right here, we see the 2 bonds. We draw in the 2 hydrogens. This carbon has 1, 2, 3, 4 sigma bonds. Since it has 4 sigma bonds, it is sp3 hybridized. Let's take a look at another molecule. Okay. This carbon right here has 2 sigma bonds, 2 pi bonds. So this carbon is sp hybridized. This carbon here, next to it, has 2 sigma bonds, 2 pi bonds again, so it's sp. This carbon here has 4 sigma bonds to it, so this is sp3. This carbon here, well, we draw in missing hydrogen. We have 1, 2, 3 sigma bonds plus 1 pi bond, so this carbon here is sp2. This carbon here, it has 1, 2 sigma bonds, 2 pi bonds. Notice, this carbon here is not part of a triple bond. It's part of 2 carbon-carbon double bonds. It is sp hybridized because it has the form the 2 sigma bonds and the 2 pi bonds. The carbon it's adjacent to, this carbon, well, it's attached to 2 hydrogens. This carbon here has 1, 2, 3 sigma bonds and 1 pi bond. So this carbon is sp2 hybridized.